Hello and welcome to our lesson video notes for lesson 8.3 over special triangles. And so we're going to kind of continue the exploration we looked at in class about special triangles. All right, you might remember that in class we looked at these explorations, and if we were to draw in the diagonal of a square, we ended up with a triangle measuring with angles 45 degrees, and 90 degrees. So that's a right triangle with the two acute angles both measuring 45. And so we were able to use that idea of a right triangle and the Pythagorean theorem to eventually realize that that diagonal that we were creating was always equal to the length of the side times the square root of 2. So that's our conclusion we came up with. The diagonal is the side multiplied by root 2, or the square root of 2. It's another way of saying that. And so one of our special triangles that we have is called a 45-45-90 triangle. And the other one is a 30-60-90, and that comes from constructing the perpendicular bisector of one side, and we get a triangle that has angles measuring 30 degrees and 60 degrees and 90. And so we were able to look at those relationships with Pythagorean theorem and realize that that vertical leg we were drawing, and it is a leg, not the hypotenuse, that was always equal to half the side of the big triangle times root 3. So that's the conclusion we came up with here, is that we take the shorter leg of these two right triangles that we came up with, okay, this length here, which is half of the full side of the equilateral triangle, and we multiplied by root 3. And so that is all set up so that we can understand these theorems about 45-45-90 triangles and 30-60-90 triangles. So we're going to look at these in our notes today. Here's our first theorem from lesson 8.3, and it states, in a 45-45-90 triangle, the legs, L, which remember would have been sides of a square, are congruent, and that length of the hypotenuse, H, is root 2 times the length of the leg. Okay, so in a 45-45-90 triangle, the legs are both called L, and the height, or I'm sorry, the hypotenuse, not height, hypotenuse is L root 2. Okay, so let's show that that is true by finding the diagonal of the following square using Pythagorean theorem with our variables here for x and x. Okay, so each side of the square is called x, so Pythagorean theorem would tell us that this length is found by doing x squared plus x squared equals c squared. Now, we might think this is a little bit difficult, but we're just going to solve this equation for c. X squared plus x squared is the same as saying 2x squared. And so to get c by itself, let's put it over here, just flip it around, and then we're going to take the square root of both sides. So c is all we have left here, because the square root of c squared is just c. And then I have the square root of 2, and then I have the square root of x squared, which you should recognize is just x. So to rewrite this differently, c equals x times the square root of 2. So there's our x times the square root of 2 to find that length of the hypotenuse. So in a 45-45-90 triangle, to go from the leg to the hypotenuse, so if you know the leg and you're trying to get the hypotenuse of a 45-45-90 triangle, we will multiply by the square root of 2. If we know the leg, we multiply it by the square root of 2 to get the hypotenuse. However, if we have the hypotenuse known, to get back to the leg, we're just going to do the opposite of that. We're going to divide by the square root of 2. If we know the hypotenuse, to go back to the leg, we divide by square root of 2. And this is pretty easy to show if we just set up our algebraic equations. Okay, so let's take a look at these examples. In a 45-45-90, we know this side is 13. That is a leg. So the other side is 13. And using our rule, the hypotenuse is that leg length times the square root of 2. But on this next example, they give you this. They give you the hypotenuse. And we're supposed to find x. Find the leg lengths, or you can call it L. If you go back up here to how these were written earlier, we can call them L. I just happen to use x this time. So this time we know the hypotenuse, and we've got to go back to the leg, so what we just said is we should divide by root 2, and I'm going to show you why that is. This side already is that x times the square root of 2. Even if I didn't know that was 10, I could express the hypotenuse as x root 2. Because you take the leg length, if I'm calling that x, then I multiply it by root 2 to get the hypotenuse. So to solve this equation for x, all we have to do is divide both sides by root 2. And that's where we get that we should divide 10 by square root of 2. Now, you'll remember we don't leave this as 10 over root 2. You have to rationalize that like we talked about in class. We have to multiply top and bottom by the square root of 2. And so when we multiply top and bottom by the square root of 2, that changes this to 10 root 2 over 2. Remember, root 2 times itself is just 2. And then 10 over 2 simplifies, and we get 5 root 2 as the length of our leg. Okay? Why don't you try this next example, sorry, it's not numbered. Try this on your own, so pause the video to give yourself enough time. Here we already know the length of this, and so we just have to find the hypotenuse. Alright, if you need more time, go ahead and pause the video. Otherwise, this is what we should get. Since the leg is 5 root 2, we just did this problem, and so we know the hypotenuse should be 10. Let me show you why that is. I take that 5 root 2, and I multiply it by the square root of 2 to find the hypotenuse. Remember, we know the leg. To go back to the hypotenuse, now we multiply by root 2. 5 root 2 times root 2 becomes 5 times 2, because root 2 times itself is 2, which is 10. So that's how I get 10. Alright, there's a couple more examples here I want you guys to go ahead and try and find. These are all 45, 45, 90 triangles. I want you to find the value of x in each one of these. Remember, if you know the leg and are looking for the hypotenuse, multiply by root 2. If you know the hypotenuse and are looking for the leg, divide by root 2, and don't forget to rationalize that denominator. Alright, if you need more time, go ahead and pause the video. Otherwise, these are the answers we should get. For 1a, x is the hypotenuse, and so all I do is take the known leg and multiply by root 2, and x is 4 root 2. 1b, again, looking for the hypotenuse, so I take the leg, multiply by root 2, and we get 5 root 2. And 1c, once again, we know the leg, 7 root 2, so I take that and multiply it by root 2, and then the root 2 times root 2 become 2, and 7 times 2 is 14. Alright, and that leads us to our next kind of special triangle, and that is a 30, 60, 90. As we talked about in yesterday's work, we have, or sorry, today, if you had class today, we had a situation where we make a 30, 60, 90 triangle by drawing the altitude on an equilateral triangle. That makes the shorter leg half the hypotenuse, and the longer leg is the shorter leg times root 3. So that's what we have here. In a 30, 60, 90, the length of the hypotenuse is 2 times the length of the shorter leg. So if I call the shorter leg s, the hypotenuse is 2s. And the length of the longer leg is root 3 times the length of the shorter leg. So if we can figure out the shorter leg first, we should be able to line that up and find the other two. Alright? Okay, and so we're going to show that again using our equilateral triangle. If I draw in that altitude, we get a 30-degree angle at the top, a 60-degree angle here, and a 90-degree angle, making this a 30, 60, 90. And with our Pythagorean theorem, if this part is x, this hypotenuse is 2x. So I'm going to say x squared plus, I'm looking for b in this case, b squared equals 2x squared. And in this case, we're going to solve for b. So I'm going to simplify that other side. 2x all squared is now 4x squared. And subtracting x squared from both sides gives me b squared equals 3x squared. And then we take the square root of both sides, and that b value is the square root of 3 and the square root of x squared, or x root 3. Alright, so if this is x, that's 2x, and b is x root 3. All right, so let's wrap up some of this information. To go from the short leg to the hypotenuse of a 30, 60, 90, to go from the short leg to the hypotenuse, we would just multiply by 2. But to go from the hypotenuse to the short leg, we would divide by 2. But to go from the short leg of a 30, 60, 90 to the long leg, we would multiply by the square root of 3. And to reverse that, to go from the long leg back to the short leg, we would divide by the square root of 3. So let's try some examples here. Now there are some other measurements we might need to know. We want to find all 3 sides here. So we know this leg is 4, and because it is across from the 30-degree angle, that makes it the short leg. Don't just go off of how it looks. Understand why it is because of the angle measure. Remember, in a triangle, the smallest angle is across from the shortest side. So the short leg is 4. Remember, the hypotenuse is twice or 2 times that short leg. So we do 2 times 4, which is 8. And if I know the short leg going to the longer leg, I multiply by root 3. So I take that 4 and multiply by root 3. Okay. In the next example, though, we start with the longer leg. It's across from the 60-degree angle, which is the longer of the 2 legs. And so what we have to do is take that and divide by root 3. And we can't leave our answer written that way. 15 divided by root 3, we need to multiply top and bottom by root 3, which gives you 15 root 3 just over 3. And we can reduce the 15 over 3 to just 5. So this short leg is 5 root 3. And now to go from that to our hypotenuse, we just multiply by 2, which means I just have to multiply the 5 by 2 and keep the root 3. So that's 10 root 3. All right, why don't you try the remaining 4 examples here. Try and find the values of all the other sides that are given. So in 3a, 3b, and 3c, make sure you solve for x and y. Pay attention to which one is the short leg, which one's the long leg, and which one's the hypotenuse. If you need any extra time, pause the video. Otherwise, these are the answers we should get. All right, for this one, we are given the hypotenuse is 9, so the short leg is just half of that. We take the hypotenuse and divide by 2 to get the short leg. So it's either 9/2 or 4.5, however you care to write that. And then we take that short leg and multiply by root 3 to get the longer leg. So we can either write it as 9/2 root 3 or 9 root 3 over 2, or you can write it as 4.5 root 3. Chances are this is the better way to write that answer. Okay? On 3a, x is the short leg, so we divide that long leg by root 3, and when we simplify it, we do get that x equals 4 root 3. And y is the hypotenuse, so I take the short leg and multiply by 2, and we get 8 root 3 for y. On 3b, it's a little bit easier because they give you the hypotenuse. Well, if I'm going from the hypotenuse to the short leg, I just divide by 2. So I take 10 and divide by 2 and I get 5. Then I take that short leg and multiply by root 3 to get the long leg. So y is 5 root 3. On 3c, once again, they give you the short leg, and that's the easiest way to go about this problem. If you know the short leg, you know the others. We double it, or multiply by 2 to get the long leg. So it's 42 for x. And then we take that short leg and multiply by root 3 to get y. So y is 21 root 3. All right, that kind of wraps up our notes over special right triangles. On Friday in class, we'll work on an assignment over these kinds of relationships, and we'll review a little bit so it makes a little more sense. And then we will also take a look at applying some of this to some real-life situations, some measurements in the real world. So you should have enough to get going with our in-class work on Friday, and hope you enjoy these notes.